So let us continue our discussion on the zeros and the coefficients of a polynomial. What is the linkage between them? And in this case, we'll talk about a cubic polynomial. Okay, a cubic polynomial in a very standard form that it is equal to ax cube plus bx square plus cx plus d, where a, b, c and d are the numbers, right? And x is the variable. The highest power here, which is 3, defines the degree of this polynomial, and this is a cubic, right? And the alternate approach of writing the cubic polynomial is, if you were given the 3 roots or the 3 zeros of a polynomial, these are the 3 solutions, let's say alpha, beta and gamma, right? Then you could say that another way of writing a cubic polynomial would be x minus alpha times x minus beta times x minus gamma, right? Let's say this is form number 2 and let's say this is my expression number 1. Then we also learned that, just like we had discussed in the quadratic polynomial, that there exists one more form, and it is also written in the form of the zeros of a polynomial. So that would be, let's say we begin with x cube that has a coefficient of 1, and then you say negative of the sum of 3 zeros, and then it goes in the coefficient of x square. Then you have the product of 2 zeros and the sum of them, right? So it will be alpha beta plus gamma times beta plus gamma times alpha, right? And that goes in the coefficient of x. And finally you have simply a product of 3 of the zeros, and that goes as a constant in this polynomial, right? So this is the third form. Just like what we learned in quadratic, all of these 3 forms are equivalent to each other. It just depends what kind of a problem you are given. So you will pick one versus another to solve your problem as quickly as you can, correct? And just like what we discussed in the quadratic polynomial, that there exists a relation between the zeros and the coefficients of these various terms in this polynomial, that the sum of 3 zeros of a polynomial is equal to negative of the coefficient of x squared divided by coefficient of x cubed, right? Likewise, you will define the product, and likewise you will define the sum of the product of the zeros, right? Taken 2 at a time, like this. And you will notice that in each one of these, it is the coefficient of x cubed that goes in the denominator, right? So with that, let's go take a look at some example problems, and we will utilize one of these 3 forms to solve our required task. And the first problem is that verify that 3, -2 and 1, these 3 numbers are the zeros of a cubic polynomial given as such, right? And the task is very simple. What we'll do is we will take one of these numbers at a time, and we will put that equal to the value of x, and we will substitute that value in this polynomial. If after substituting that specific value, if the net result of this polynomial, this expression becomes equal to 0, then we will say that that specific value is a solution of this polynomial, right? So when I substitute x equal 3, I get that it will become 3 cube minus twice of 3 square minus 5 times 3 plus 6. So let's solve these mathematics, get rid of the cubes and squares, and you find that these numbers become 27 minus 18 minus 15 plus 6. Sum them, subtract them, and you'll find that this is equal to 0. So what this tells me that, yes, x equal 3 is indeed a 0 of this cubic polynomial. Let's take one more number. In this case, I'll pick x equal 1. So when I do that, I'll simply substitute that value of x. It will become 1 cube minus twice of 1 square minus 5 times 1 plus 6. Simple to solve, it becomes equal to 0. So yes, it is also a solution of this polynomial. So I will leave the third number, which is -2, for you to analyze that when you substitute this value of -2 in this expression, what result do you get? Now let's take a look at another problem. So this task is slightly different. In this one, we are supposed to find a cubic polynomial, and we are given the 3 zeros. Their values are 2, -3 and 4. Okay. Now just few seconds ago, we learned about 3 different forms of a cubic polynomial. I'm going to pick the one which was at the very last, and it was expressed in terms of the three zeros. Okay, so sum of three zeros goes in the coefficient of x square. Sum of the product of two zeros taken two at a time will go in the coefficient of x, and then finally you have alpha, beta, gamma, the three zeros multiplied together, and this will give you your required expression. All that is left is substitute these three values. Let's say this is alpha, this is beta, and this is gamma in this expression, and then you will get your required answer, correct? So as I do it, I get x cubed minus alpha plus beta plus gamma. It is 2 plus minus 3 plus 4, and that goes with x square plus 2 times minus 3 plus negative 3 times 4 plus 4 times 2, and that goes with x minus 2 times negative 3 times 4, right? As you expand and solve all of this multiplication, addition, subtraction, you will get that your required expression is x cubed minus 3x square minus 10x plus 24, right? So you see that how easy it is to obtain your required polynomial given these three forms. But what really depends on is how well you know the three different forms of a cubic polynomial. So this was rather a simple approach. The other approach someone might take is that I could take this one as well, that I'll take one variable at a time and then I'll subtract it from x and then multiply these three values, x minus minus 3, right? And then you will have x minus 4. But this method will require you to multiply and open up the parenthesis 3 times. This is a rather long method compared to the method that we earlier took to solve our problem, right? So this is where we pause, that we wanted to learn about what are the zeros and the coefficients of a polynomial, and we took example of a cubic polynomial. We learned how to build a polynomial, and we learned that if you are given zeros, how to check whether they are indeed the zeros or not. With that, we will take a pause here, and in our next tutorial, we'll go and talk about how to divide one polynomial with another polynomial.